Okay, let's continue with section 11.5, letter D. Powerball is a multi-state lottery played in most U.S. states. It is the first lottery game to randomly draw numbers from two drums. The game is set up so that each player chooses 5 different numbers from 1 to 59 and one Powerball number from 1 to 35. Twice per week, 5 white balls are drawn randomly from a drum with 59 white balls, numbered 1 to 59, and then one red Powerball is drawn randomly from a drum with 35 red balls, numbered 1 to 35. A player wins the jackpot by matching all 5 numbers drawn from the white balls in any order and matching the number on the red Powerball. Okay, so how many combinations are possible to draw numbers? I like to draw a little picture so that it's easier for me to picture what is happening here. And so we know that there are white balls, right? So there's 2 drums. Let's just say these are the white balls, okay? And they are numbered 1 to 59, right? And we're choosing 5, okay? And then there are going to be the red Powerballs, right? These are numbered 1 to 35. And we are choosing 1. Okay, so how many combinations are possible to draw numbers? This is going to be our denominator, right, for the total number of combinations. Order does not matter, right? So we are looking at, let's see, the white balls and then the red balls, right? So within these 2 categories, we can multiply our 2 totals here to get our grand total of how many combinations are possible. Let's see, white balls, we're choosing 5 out of 59. Order does not matter, that's a combination, and it's 59. Choose 5. And red, right? Obviously, order doesn't matter, I'm just choosing 1. And there are 35, and I'm choosing 1, right? So you can use your formulas or you can put this in your calculator. I would suggest your calculator here. And our total should be 175,223,510. Okay, with 1 Powerball ticket, what's the probability of winning the jackpot, right? So what's the probability of winning, right, with 1 ticket? Well, if you have 1 ticket, you have 1 chance, right? So the number of ways of winning the jackpot would be 1 out of the total. So you have pretty small chance of winning that Powerball, right, with 1 ticket. And that is how you set up these different types of lottery problems that you may come across. Alrighty, let's continue another one. A city council consists of 6 Democrats and 4 Republicans. All right, so we have, let's see, 6 Democrats and we have 4 Republicans. So if a committee of 3 people is selected, how many different committees are possible, right? So we're going to committee, right, of 3 people. So right now we're not finding the probability of anything, we're just how many different committees are possible. Well, does order matter here? No, it does not, right? So we know this is a combination. And I'm choosing from how many? Well, there are a total of 10, 6 Democrats, 4 Republicans, and I'm choosing 3 from there. So use your formula or put this in your calculator. You should have a total of 120 possibilities. All right, so here's the probability question, right? What's the probability of selecting 1 Democrat and 2 Republicans? Well, before we find the probability, we have to figure out how many ways this can happen, right? Democrats, Republicans. Okay, so Democrats, let's see. Democrats, it's a combination, order doesn't matter. There are 6 Democrats, and I'm choosing 1. Right, so that's a combination. We'll multiply that with the Republicans. Again, order doesn't matter, it's a combination. How many are there? There are 4, and we are choosing 2. So do the multiplication there. We should have a total of 36 possibilities. Okay, so that's being super specific with picking 1 Democrat and 2 Republicans, right? 36 ways that can happen. And so now if we're asked for the probability, right, of choosing 1 Democrat and 2 Republicans, right, we know that can happen 36 ways out of the total 120, right? And I put that in lowest terms, we are at 3/10, right? Divide numerator and denominator by 12, right? And they'll give us a 0.3 or 30% chance. All right, the last one. We have a box contains 25 transistors, 6 which are defective. Okay, 6 of which are defective. And so, let's see, if we are looking at the total number of combinations, if 6 are selected, again, we're looking for the total. This is going to be our denominator, right? This is a combination. Order doesn't matter. I'm just picking these out of the complete pile of transistors. There's 25, and I'm picking 6. Okay, so that's 177,100, right? Different combinations if I'm picking 6 out of 25. Now find the probability that all are defective. When we're figuring out the probability that all are defective, right, let's ask ourselves, how many are we choosing from? Well, there are a total of 6 that are defective, right? What's the probability that I choose all 6 and that they're defective, right? So probability of 6 choose 6 is 1. And that's going to give us 1 out of the total 177,100. All right, what about the probability that none are defective, right? Well, how many do I have? I have 25 transistors, 6 are defective. How many are not defective? How many are good? Well, I have 25 total, 6 defective, 25 minus 6, that means 19 are not defective, right? So when I'm figuring out the possibilities here, there are 19 that are good, not defective, and I choose 6 of those. Combination of 19 choose 6 is 27,132, and that's going to be over the total, right, of possibilities, 177,100. Alrighty, so hope these are helpful for you when you're doing your homework. If you have questions, please don't hesitate to reach out.